Good afternoon, everyone. Thank you very much for joining us today. Today's webinar topic is early season nutrient management. And with us, we have Dr. Hans-Walter Peterson. He's the Viticulture Extension Specialist from Cornell University, the Finger Lakes program. So I'll let him introduce himself and then we'll start off. If you have any questions, please put them in the chat towards the end of the presentation, and then we'll have a discussion before we finish off. Thank you very much, and I hope you enjoyed the session today.
All right. Okay. Of course. Yeah. Okay. Come on. Come on. We can do this. There it is. Yes?
Perfect. Yes.
Okay. Great. Okay. Like we were saying before we started.
Yeah, pretty much. Exactly.
Nothing can go smoothly. So thanks for the invitation to do this. I haven't given a nutrient talk for a while, so it's good to kind of brush some of this stuff off and revisit it. So this is great. So I previously mentioned, my name is Hans-Walter Peterson. I'm the viticulturist in the Finger Lakes region for Cornell. I've been here since 2007. And before that, I was in the Lake Erie region, which is almost all juice grape production. So Concord and Niagara mostly for about 6 years before that. So but here in the Finger Lakes, we have juice grape producers, table grape producers, small table grape, but and then obviously wine producers as well. So I'm going to just kind of give not quite 101, but some nutrition 101 stuff. And then, but I'm happy to take questions. I'll try to stop a couple of different times during the talk and ask if there are any questions, and we can kind of, if folks want to kind of go in a different direction, that's totally fine by me, or ask questions about something that's just been bugging you. But like Katarina said, should have some time towards the end as well. So, when we talk about nutrition, we've been hearing about nutrition all of our lives, maybe in just more different ways. So, I mean, we've always known how important it is for our own health. And so the same thing is important for grapes. We need nutrients in order to give our bodies, and plants need the same thing to function, to do all the functions that they need to do. So for us, it's to, be able to respire, to digest our food, to walk, to move, to sing and dance, whatever we want to do. And for plants, it's the same thing. They need nutrients in order to grow shoots and leaves, to produce fruit, to ripen that fruit, to prepare themselves to survive winter, to defend themselves against pests, all sorts of things. So nutrition is all about giving vines the building blocks of what they need in order to survive and to be productive. And so that's kind of what we're going after here. And so basically in a single slide, here's all of the nutrients that we think about that plants need. So the three biggest ones, a lot of people, when we talk about nutrients, might think about things like nitrogen and potassium and phosphorus. But the three biggest nutrients that plants need are ones that they get pretty readily from the environment, basically carbon, hydrogen, and oxygen. Those obviously come from air and water more so than from any kind of soil applications or soil from the soil environment. And so, but those are really the big three in plant nutrients. But as far as when we talk about nutrient management, we're talking about the things that come from the soil primarily. And so those are split into two basic groups, what we call the macronutrients and the micronutrients. And as you might surmise from the names, macros you need more of, micros you need less of. Doesn't mean they're less important, but you need less of them. So in macronutrients, when we talk about amounts in a plant, we talk about percentage. So basically, same thing as parts per 100, right? So 1% is 1 part in 100. So in plant tissue, we might talk about nitrogen taking up 2% of the tissue sample, for example. In micronutrients, we talk about generally parts per million. So we're talking about much smaller amounts, but again, just serve very important functions, but just in very small amounts compared to the macronutrients of nitrogen, potassium, phosphorus, magnesium, sulfur, and calcium. So, this is the list of things that we worry about. We're not going to talk about every single one of these today because there are whole classes devoted to this. But we're just going to give kind of an overview of how to think about managing these, a little bit of specifics about two of the big ones, nitrogen and potassium, and why those are so important. But again, we can go into other nutrients or other questions as we go through. So the way I like to think about nutrient management is basically from the soil up. And so basically we need to understand kind of where are we starting from? So what are the conditions of the soils that we're starting at? So this comes from site selection. This goes all the way back to what is the site that you are planting your vineyard on or that your vineyard is already on. So understanding what the soil character and content, basically what is the soil made up of? How much variation is there across the vineyard? Do you know that one side of the vineyard is heavier clay and another side is very silty or very sandy or gravelly? That's going to have an influence on nutrient availability and nutrient uptake. That number 2 there, soil amendments, that's actually probably not the right word for it, but kind of soil properties. So things like percent organic matter, pH, depth, those are things that we can influence. And so we can amend the soil in order to influence those. Amendments I tend to think of as things we actually add to it, which you can add to influence those things. Anyway, and then the thing that the organs of the plant that are that provide the nutrients are the roots. And so we need to understand what is the environment for the roots like. So that goes back to the soil conditions, but also things like our vines, are they own rooted or are they grafted? If they're grafted, what kind of rootstock are they on? That can have an influence on rooting distribution and therefore nutrient uptake as well. The shoots and the fruit, those are the big sinks. Those are the, when we talk about nutrient management and we talk about vine physiology in a lot of ways, we talk about sources and sinks. And so sources would be things like the leaves for photosynthesis or the roots bringing up nutrients. The sinks are the things that demand those resources. So in the case of nutrients, it's the shoots or even the shoot tips as they're growing out. And then as the fruit develops, they become sinks for nutrients as well. So basically, what is the demand of those sinks compared to what is being supplied? And then kind of you think about what's the difference between what's being supplied and what's being demanded. Then what do we need to add? What do we need to supplement? Putting down, liquid, granular, whatever, and how efficiently do the plants take those up? And there are different fertilizers, different types of nutrients have different kind of efficiencies for uptake. And I'll touch a little bit on that a little bit later. So like I said, we kind of think of this from a ground up, literally, perspective of what's the soils like, what is the environment for the roots, what kind of demand is there from the plants, and then based on the kind of the supplying power of our site and the demand side of the equation, what do we need to fill in the gap, if anything? So basically, here are a couple of the questions that we'll try to address, at least to some extent, during this talk today. And again, if there are others, please feel free to throw them out there. How many nutrients do the vines lose every year? It's an important question. We put stuff in, but stuff gets taken away, right? So what do we have to replace in a given season? What levels of nutrients do the vines need to have? Kind of what is optimal, what is deficient, what is excessive? What does the soil already supply? So if we know what the vines need and then what the soil can supply, then we know maybe what we have to add through various different kinds of materials. And then how much do we supply and how do we do that? So we'll get into some of that. And again, if I don't get to specifics that you might have, feel free to ask. So first things first, let's talk a little bit about nutrient loss. So we lose nutrients through basically tissues coming off the vine. And so that happens basically in 3 ways. Harvest. So we take fruit off the vines at the end of the year. So that pulls a bunch of matter, dry matter, or fresh plant material off there. Leaf fall. So the leaves are full of nutrients, and when they fall off in the fall and the winter time, the vines lose those compounds, those nutrients to the ground. And then when we prune, obviously there's nutrients. There are substances within the wood that we take off every year. We're taking off those and we're removing them from the plant. And so those are 3 different ways that we lose nutrients each year. So a bunch of different work has been done in different times. Looking at this, there's the most recent work that's been done on this is a project that's been funded by the US government. And I apologize right now, this is all going to be in English units. It's not going to be in metric, so I apologize for that already. But there's been a large project going on the past few years here in the US, looking at kind of improving our understanding of nutrient management. And so based on a bunch of their sampling that they've done over the past few years as part of that project, these are kind of our best estimates now as to essentially good estimates of how much of each of these nutrients you lose when you pick a ton of grapes from an acre. So if you want to go per hectare, you multiply by about 2, a little over 2. And so basically you look at the 2 biggest ones by far, and we'll just focus here on this 1 ton per acre here because that's per ton. You can see we actually lose more than twice as much potassium as nitrogen. We think about nitrogen as a really big nutrient in the vines, and it is, but we lose even more potassium when we take at harvest time because potassium is incredibly important in ripening and gets used a lot in ripening. If any of you ever use grape pumice, especially fresh pumice, and put that back out in the vineyard, if you used fresh grape skins, pressings after you're done, those skins can be really high in potassium. And so if you put a lot of them into the vineyard, you might actually cause kind of a potassium overload into the vineyard because there's so much of it in there. There's, I think, more than most growers realize when we first present this information to them. So per ton, there's about 6 pounds per ton. Nitrogen, there's about 2.5 pounds. And then phosphorus and magnesium, 2 of the other macronutrients, less so, obviously. So we can see, especially for potassium, we pull a lot out of the vineyard. So if you pull 5 tons per acre, which is not an unusual amount to pull out in a commercial vineyard, no matter what you're growing, if you have good, healthy vines, you can be pulling out 30 pounds per acre of potassium. And so that's good to know. What is the, this is part of the nutrient budget that you have in your vineyard. So at harvest, you're taking out this much. Now, again, remember then, we're also losing nutrients to leaves and to prunings as well. Those can get recycled back into the soils if excuse me, if those are left to just decompose. But if leaves get blown out of the vineyard, then obviously that goes away. If you remove prunings from the vineyard because they might be diseased or something like that, then that's going to be lost. So again, there's something that you need to think about in the budget. More nitrogen tends to be than potassium tends to be in the leaves and the shoots, just because that's plant material and not so much the reproductive organs, the grapes. And so, but again, nitrogen, potassium still are the biggest ones that we lose of all of those. So that's kind of that part of the equation. Kind of what do we lose every year? How much do vines need? And I don't know if some of you might have heard this phrase in various forms or another, but I've heard it a lot from growers, especially when I first started in my career here in New York. A little extra fertilizer is cheap insurance. And when I think of cheap insurance, if any of you know the movie Groundhog Day, I think of Ned Ryerson. But when fertilizer was cheap, maybe that was true. I probably wasn't true, but fertilizer is no longer cheap, both from a financial standpoint and from an environmental impact standpoint. So we really shouldn't be thinking about this phrase as a little extra fertilizer is cheap insurance, really as if we're going to be good, efficient managers of our vineyards. We should be giving the vines what they need, where they need it, when they need it, and try to avoid giving any more than that. And so again, we'll talk a little bit more about that. So if kind of one of those things of if you think they need 25 pounds per hectare or 10 kilograms per hectare, well, what's 20 kilograms per hectare going to hurt? They'll still get what they need. Well, I'm not sure we should be doing that. So part of the reason that we're worried about putting excess fertilizer down and putting just a little extra cheap insurance down is not just because of cost implications, but because of environmental implications. And so these are two photos. The one on the left is from Lake Erie. So up towards the upper right part of Lake Erie is where Buffalo is. And this whole southern shoreline, southern shoreline here is what we call the Lake Erie Grape Belt. And so there's a lot of vineyards along here. And there's a lot of other farming that happens in this watershed as well. Farming, people with big lawns and all sorts of things that are going on. But you can see this giant algae bloom that built up. And this is about 10 years ago, 10 or 12 years ago. But this has become a more common occurrence in Lake Erie. And then if you go over on the right-hand side, this is a shot from this is at the base of the Mississippi River. Here's the delta right around here. This is basically a hypoxic dead zone. There's almost no oxygen in the water down here. And so basically what's happening is that there's a whole lot of runoff coming, not just from ag, but all sorts of runoff, carrying nutrients down. And those nutrients are feeding plankton that then gobbles up all the oxygen. So basically nothing else can live here. And so what we're seeing is things like fisheries and other aquatic habitats are being severely impacted by this dead zone outside the Mississippi Delta. So excess nutrients can have a major environmental effect. In the east, a lot of our vineyards, especially here in New York, a lot of our vineyards are near bodies of water, and regulations and expectations of the public are growing more and more intense and of greater concern. And so we need to be the best stewards of our vineyards as we possibly can. And whether that means surface waters, whether that means nitrates leaching down into groundwater and getting into wells, that could be another issue down in rural areas. So again, adding more fertilizer as cheap insurance has bigger implications than just cost. We also have environmental impacts that we have to deal with, and we really need to be taking care of those. All right, I'm just going to stop and take a drink of water, but ask if there are any quick questions that might be hanging out there yet. Anything yet?
No questions so far.
Okay. All right. Hearing none, we will continue. So what are the sources of nutrients? How do the plants get them in the first place? Well, we talked about carbon and hydrogen and oxygen, getting it from the air and the water. And so if you live in an arid climate or kind of a Mediterranean climate where it's very dry all summer or all season, then obviously you need to think about how are nutrients being added through water, not just hydrogen and oxygen and carbon or hydrogen and oxygen. But also, again, we're looking at what are the soil-borne sources of nutrients, the macro and the micronutrients. So the biggest source of nutrients by far is just the soil where they're planted. And so soils are made up of minerals. And so they contain all of those different nutrients, macro and micro, to different levels, depending on the parent materials, how they've been worked in the past, what kind of plants have been grown on them. There's all sorts of things that can influence that. But basically, there are two ways that the soil itself supplies nutrients. One of them is by the organic matter that's in the soil. So dead plant material, dead animal material, things like that are getting broken down by the microbes. That organic matter gets broken down, and part of what they produce are plant available nutrients. And the biggest one from organic matter is nitrogen. So basically, the general rule of thumb is that for every 1% organic matter you have in your soils, that is able to supply about 15, maybe 20 pounds of nitrogen per acre per year to your vineyard. And so if you have a soil that has 3% organic matter, which is not uncommon here in New York at all, we're supplying somewhere between 45 and 60 pounds of nitrogen per acre, which quite frankly is plenty for a lot of our vineyards. We don't need much more nitrogen than that. So as long as we have a good, healthy microbial community and we have organic matter that's kind of being cycled through the vineyard ecosystem, we get most of the nitrogen that we need from the soil as it is. And so that helps to, that is a stable source of nutrients. It is a kind of a recurring, it's a free one, which is also nice. If you have lower organic matter or if you have soils that have some other limitations, there can be some things that impact that ability to supply that nitrogen. But just as a rule of thumb, that 1% to 15 pounds is about where we sit. The other way that soils supply nitrogen is just basically weatherization of those minerals. So the parent material, the rock that basically formed and those soils kind of built off of. So whether it's limestone or shale or granite or basalt or whatever kinds of rock that comes out of that, those have those things like potassium and calcium and phosphorus and all that kind of stuff is all in that parent material. And then basically as it breaks down over decades, centuries, millennia, those nutrients are released into the soil environment. And so the roots are able to take advantage of that. One of the big ones in this example is potassium. Almost zero potassium gets liberated from organic matter. It's almost all nitrogen, carbon, and oxygen. And so potassium has to come from the weatherization of minerals. So some soils have plenty of potassium in them because the parent materials are potassium rich. There are other soils that are very low in potassium. And so the only way that we can get potassium into the system is by adding it if it's not coming from the parent material. Biomass, that kind of goes back into the organic matter situation, but things like cover crops and prunings, if you get prunings off the vines and then you chop them up and they break down into the soil, you're adding nutrients back into that system. Cover crops can do the same thing. They can pull nutrients from, excuse me, from different parts of the vineyard or up from different depths and break down into plant available sources of nutrients. And basically kind of add to the nutrient pool as well. Another source that the vines rely on, especially early in the season, are basically nutrients that have been packed away and put in storage in places like the roots and the trunk and the canes or cordons, the dormant wood, basically woody tissues. And so early in the season, the vine is actually not picking up almost any nutrients from the soil because the roots are just starting to push out new root hairs, small roots that are responsible for most of the uptake. Most of the nutrients that are needed between bud break and bloom come from the reserves within the plant. During the season then, if there's a shortage of nutrients, they can be supplied by some of the older leaves, for example. And so when we see nutrient deficiency symptoms show up in older leaves, you can sometimes see, I'll have a couple of pictures later on, but yellowing between the veins on older leaves or things like that. That basically means those leaves are exporting things like magnesium or potassium and moving it up into the leaves that are more active. And so the older leaves can be a source of nutrients as well. Excuse me. And then finally, whatever we supplement ourselves as a grower. So then we also have to think about what are some things that influence the uptake of those nutrients. So I mentioned before, kind of what is the soil environment like around the roots? Because the roots need, in order to take up nutrients, the roots need to respire. Respiration is just a process by way we get energy, whether it's plants, plant roots, or us. They need the same thing. They need oxygen in order to create an energy to fulfill an energy pathway that allows for that uptake of water and nutrients. And so if they don't have oxygen, they don't function as well. And so if we have soils that are compacted or saturated, that means there's not as much oxygen in there, and therefore the roots can't do their jobs. And so this is why we talk about being concerned about compaction layers, especially if they form around roots, or soils that stay waterlogged for too long. There's an old, the old saying of grapevines don't like wet feet. And this is the reason why, is that the roots need oxygen in order to function properly. The other major soil condition we think about is pH, which is a measure of the acidity. Basically, the pH influences the form of each of these nutrients. So we don't take up nitrogen just as a nitrogen atom. We take up plants take up nitrogen either primarily in either ammonium, so the NH4 plus ion, or nitrate, which is NO3 negative. And so those two compounds have an electric charge because of their structure. And the soil pH then can influence whether those get picked up or not, whether those get held on by the soil particles that the plant root can then take up, or if they get flushed through the system, for example. So soil particles tend to be negatively charged. And so negatively charged ions like nitrate don't stick around in solution very well because they basically don't magnetically attract to the negatively charged soil particles. So most of our nutrients are positively charged. And so they do get stuck on things like potassium and magnesium. The forms that get taken up by plants have a positive charge, and therefore they get attracted to those soil particles, especially clay particles. But negative ions, nitrate is one, boron, the form of boron that it takes up is another one that can be that is negatively charged. And so we want to have kind of a combination of types of nutrients when we have, I'll get into that later. Basically, but the pH affects what kind of availability there is, and I'll get into some examples about that in a minute. Soil moisture content is really important. Basically, a lot of the nutrients get picked up through basically diffusion, which basically means if there's a dearth of that nutrient near the root hair, but there's more of it nearby. If there's a higher concentration here and a lower concentration here, more of it will move towards that lower concentration area, and the root hair will be able to pick that up. But that diffusion requires water. And so if there's no water in the soil, if the soil is basically down to no free water or no soil water in the solution, that diffusion can't happen. And so the roots can't take up those nutrients. So even if they're in soil, there needs to be some amount of soil moisture in order for that uptake to happen. There are also differences between varieties and rootstocks. The varieties tends to be a little bit more related to what species you have. So in a place like Canada and in Nova Scotia, where you have multi-species hybrids, there can be things all over the board, but we know things like Concord, for example, the Labrusca varieties tend to be more aggressive with certain varieties because they've adapted to certain soil conditions than something like Riesling or Chardonnay, which is adapted from a different type of region. So that can be an influence. Rootstocks come from different species as well, and so they can have different uptake characteristics, and I'll show you a little bit of an example of that in a bit too. So this is just a graph kind of illustrating what I was saying before about how important oxygen is in the soil profile in order to take up nutrients. And so basically you can see here, the more oxygen you have up to a point, the uptake rate of nutrients improves. And so basically we need some oxygen in order for that proper root functioning to happen. And so if you have soils that are really heavy clays, for example, there's some very heavy clay soils over on the Niagara Bench, for example, over in Ontario. And those those vines really, they need to have a lot of work done with cover crops and other things to try to make more space for oxygen to be able to get into this root zone in order for that, for healthy root environment to exist. So that's just, again, just kind of illustrating the need for oxygen for nutrient uptake. This one talks, this graphic basically shows the influence of pH. I was mentioning the importance of how pH can, how acidity can make a difference. And so down here at the very bottom, you can see we go from everywhere from, if you remember your high school chemistry, very low numbers mean very acidic soils, and high numbers mean very what we call alkaline or basic soils. And so down here at 4.0, this is really tart. This is like we're getting down into areas where those of you who make wine know we can be in the 3.5 to 4 pH range in with a lot of wines. And so, but you can see then with each of the nutrients how they are influenced by pH. So for things like iron and manganese and boron, because of the chemistry and how they relate to pH, they are more available at these low pHs. And so, for example, iron, as you get higher and higher in pH, if you have a limestone-based soil, for example, you can have some real problems with iron deficiencies because that iron, it's not that the iron isn't there, it's just in a form that's not available to the plant. So if you have a vineyard where the soil pH is 8, and there can be some more so in the west than in the east, I think, but there can be some pockets. If you have a soil pH of 8, you might be dealing with an iron deficiency and have to do some kind of supplementing there. On the other hand, if you have a really acidic soil down around 5 to 5.5, you're going to have some real issues potentially with phosphorus availability, with potassium, with sulfur, but you'll have plenty of these micronutrients available. And so you can kind of see where the sweet spot is. The sweet spot is somewhere here between 6 and 7.5. For nutrient availability. And that's really where we like to see our pHs for most vineyards. If you have what we call native varieties, Labruscas, so Concord, Niagara, you can tend to be a little bit, whoa, that was fun. I apologize. There we go. So if you're in this, if you're a lot more on, if you have Concord, you want to be a little bit more on the acidic range because they evolved in more acidic soils here in the Eastern North America. And so they don't take up as much iron and manganese because it's so available. Something like hybrids, you want to be more in that 6 to 7 range, and vinifera is that 6 to 7.5 as well. So we kind of want to look just for that sweet spot. Again, so this is a situation where if you have acid soils, you can have certain nutrients that don't get taken up as well, and you can have things that look like this chlorosis. This is just some data kind of backing up what I was talking about. So this is available magnesium in soil. So these are a whole bunch of soil tests that a colleague of mine, data from a colleague of mine put together years ago. But basically looking at the soil pH from each of those tests. So each of these dots is a single soil test. And then what the magnesium is in parts per million in that soil. You can see the amount of available magnesium shoots up as we go from pH of 4 to pH of 6 to 7. So magnesium heavily related to pH. Also, I didn't have it on the chart there, but aluminum, this is actually probably one of the biggest issues with low pH, is that aluminum is actually toxic to roots. So if roots take up too much aluminum, it can kill the cells in the roots and actually hurt uptake of other nutrients as well. And so this is part of the reason that at a place like the Lake Erie Concord Belt I was talking about, there are native soils that are in this 4 to 5 pH range, the very acidic soils. And we really don't want to be there partly because the aluminum is so high and it really has a negative impact on availability of these nutrients as well. And so we really want to get it over 5 so we get more into this into the low hundreds at least of aluminum so that they're not nearly as impactful to roots. And again, this is kind of what I was talking about with iron as well. Iron is highly available in an acidic environment and very little available to plants in a more basic environment. And so again, if you have a soil that's above 7 or so, 6.5, 7, you might need to be adding iron on a regular basis just because the soils won't allow you to, it's harder for the plants to pick that up. This just kind of gets at something. This is relating back to soil pH, but I also want to just mention really briefly about in addition to soil pH, when we talk about 3 of the important cations, the macronutrients, and so that's potassium, magnesium, and calcium, the uptake channels on the roots for those nutrients are all similar. And so basically, if you have an excess of one of those, you can hinder the uptake of the other ones. And so this chart here is showing the influence of soil pH on these two. So again, over here in the red is magnesium. So at a low pH, magnesium is not very available. You increase the pH, it's more available, and the reverse for potassium. But the other thing I wanted to just mention is that even if the soil pH was held steady, if you have a high amount of potassium in your soil, you may still have a high amount of magnesium, but you're going to suppress its uptake. And so one of the things that we look for, and one of the reasons that we suggest not just having soil tests, but also tissue tests, is that the soil tests tell you what is in the soil, what is in the tank, what's the supply reservoir look like. But a tissue test is going to tell you what's actually getting into the vine and what's being distributed in the vine. And so that's where you may see some of those conflicting or those interactions that are happening between these 3 nutrients. And so if you have very high tissue magnesium, for example, you might see very low tissue potassium, even if the soil levels are what we would consider adequate. So when might you see that? If you have to raise the pH and you use a lot of dolomitic limestone. Dolomitic limestone has a lot of magnesium in it relative to non-dolomitic limestone, calcitic limestone. And so you can add a whole slug of magnesium to a soil environment and suppress potassium uptake, for example. These are some graphs from, and this gets back to the rootstock thing that I was mentioning before. This was a study done out in California a number of years ago. And they looked at 3 different cultivars. So Chardonnay, Cabernet Sauvignon, and Zinfandel in 3 different regions of California. The Delta, which is kind of between Sacramento and San Francisco, basically. And then up in Amador County, which is over in the Sierra foothills to the west of Sacramento, kind of on the eastern side of the state. And basically look at these are graphs of looking at nutrients, and they used a whole bunch of different rootstocks. So they had the same, within each site, they had the same cultivar. So Chardonnay in the green, Cabernet here in the red, and Zinfandel in the purple. And so same site, pretty similar across the site, similar type of soil, but you can see very different uptake of both potassium and nitrogen. And the number here is basically what the average is across all of the rootstocks. So for example, we'll look at one here. This is the rootstock called 420A. 420A is a rootstock that has a reputation for being very low vigor. So you'd want to put it in a very fertile site. And this kind of explains why that's the case. It is not very good at picking up nutrients compared to some of the other rootstocks. And so it's not going to encourage a whole ton of growth. For example, if you have a lot of nitrogen going into the plant, you'll get a lot of leaves, you'll get a lot of shoot growth. And so what we see here is that 420A, along with a couple of the others, 1616C, 03916, Harmony, these are some other rootstocks, are well below average when it comes to nitrate getting picked up. Other ones are very aggressive about it. 110R and 1103P, for example. Those are considered high vigor rootstocks in general because this is one reason. If we look at potassium, we see a similar kind of thing. We see 420A, again, here well below average in all three locations. So we have very low here in the Delta Chardonnay, a little bit less low, but still well below average in the Cabernet, and also here in the Zinfandel. So basically just a way of saying rootstocks can have a big influence on nutrient uptake as well. I will say that the differences they see in rootstocks in an arid region like California or even Eastern Washington, places like that, we don't necessarily translate directly to Eastern conditions. And a big reason of that is because we get rain during the season. If you supply even a low vigor rootstock with plenty of water and plenty of nutrients, kind of an overabundance of it, it will grow more shoots and leaves and fruit. And so a couple of rootstocks that are considered low vigor out in western U.S., Riparia gloire is kind of a classic one. We've used Riparia gloire in a few different experiments out here in different times and places, and it's not nearly as much of a dwarfing or a low vigor rootstock as it's purported to be out in the West. So take this with a bit of grain of sand, salt, sand, sugar, whatever. But again, rootstock can have an influence. Here's another example. Basically, this is another one, 4453. If we just look at the petiole potassium, 4453 is a rootstock that's been developed for use. Not developed, but it's very useful in soils with high magnesium. And there are some soils that have natively high magnesium levels. And so we want a rootstock in that case because I mentioned that conflict, that competition between potassium and magnesium and calcium. We need something that's going to be good at picking up something like potassium if there's a lot of magnesium in the soil. And so this is kind of evidence of showing that 4453 is really good at that. So it had it in the Delta Chardonnay, it picked up more potassium than any other, picked up almost 8 times as much as the 420A, and it has similar pattern across all the other sites as well. All right, I'll stop again here and see if there are any questions before we move on.
We did have a hand up a little bit ago, so if this viewer would like to ask that question or put the comment in the chat, I'm more than happy to say it out loud or allow to talk button as well. Nope.
Okay.
We can keep going.
All right. So I always like to talk about this this project. So when I worked out in Western New York in the Lake Erie belt, we did a project, and the person here in the green sweatshirt here on the left side of the picture is Terry Bates, and he is a researcher with Cornell who is based out in Western New York. And a number of years ago, he proposed a project called the Big Dig. And basically what we did is that at several times during the season, I think about 8 or 10, literally we went out and dug up whole vines. These are all concord vines, to understand where are the what are the nutrient components, what are the dry matter, how much starch and carbohydrates and all these kinds of things are in the different parts of the vines at different times of the year. And so this is a way of us just kind of understanding a little bit more about where nutrients go, kind of how they cycle during a growing season. And so I just wanted to highlight a couple of things out of here. So one of the big things that that we learned about this is just to what extent the root system, the below ground system, acts as a storage vessel for grapevines. And so basically what we found is that in a dormant grapevine, you can see the dry weight here, about 40% of the dry weight of the grapevine. So that's water removed basically. So it's just doesn't count water weight. 41% of the dry weight of a mature concord vine was above ground, 60% of it was below ground. So right there, that just tells you how much of how large of a reserve this is and how important this is, especially like I was talking about earlier, for that early season growth. If we look at some specific parts of that dry weight, the amount of starch, almost all of the starch is below ground. Very little bit is stored up above ground. There's all sorts of other things. There's cellulose and all sorts of things up there, but the starch, those complex sugars that can get liberated later on and act as sources of energy for the early growing season, almost all of it gets stored in the roots and then gets reactivated in the spring. And so that's what's happening basically right now. As our vines are breaking bud, most of the shoots here in the Finger Lakes are 2 to 4 inches for the most part. All of the nutrients that are feeding those buds and all the energy that's going to grow those buds right now is coming from internal sources from below ground for the most part. 75% of the nitrogen in the vine when it's dormant it's below ground. 77% of the phosphorus is below ground. So again, that's that root system that acts as that storage reservoir for especially early season growth. And then this is how they kind of move through the system during the season. So this doesn't contain phosphorus, but here is, so here's the dry weight. These are the numbers on the right side. So this is the weight of the whole vine. So grams per vine, so 2 kilograms, 2.5 kilograms, 3 kilograms. So this is roots, trunk, shoots, leaves, clusters, everything. So we start early in the season. This is right at bud break, basically. So we start with a lot of starch in the whole vine. Again, this is the whole vine. This isn't just specific pieces. And then we have very low amounts of nitrogen relative to that, and then relatively low dry weight in the vine. And we see the dry weight slowly pick up. This is from bud break through bloom. And then all of a sudden, once we hit bloom, we get both fruit growing and very rapid, a lot of times fruit and shoot and leaf growth. And so we see this rapid increase in dry weight. We see the amount of starch going up. This is because of photosynthesis, obviously, right? So here's that drawdown early in the season to supply this growth. And then once the roots kick in and once the leaves are fully functional, by the time we get to bloom, now we see this big production of starches and sugars that go throughout the vine. When we hit harvest then, what's happening here? Obviously that's again, I've got to stop messing with my wheel. So that's the fruit getting picked off. And so now we're back to this about 2 kilograms of total dry weight. Well, how do we get from here back down to here? Because if that's where we start a season, oh, right, that's where the pruning happens. So we take off, in this case, in this vineyard, we're taking off about 1.5 kilograms per vine before we got back down to this 500 when we took off prunings. All right. So that's just an example then of how the cycling happens. So and we can see nitrogen here, much lower numbers than the starch. But again, this increase that goes until we hit veraison, basically, and then it starts to tail off again. The other lesson we kind of learned about this, and again, this is in Concords, but the general idea can pretty much applies for grapevines in general. I always thought this was kind of interesting. Basically, the total nitrogen in the vine from year to year stays almost stagnant, stays even. Basically, we get nitrogen that stays in the vine. This is stuff that's getting remobilized. So we're not adding new nitrogen from the soil. It's mostly just getting redistributed from within the vine. So that's why there's kind of almost like a net zero here. And then all of a sudden, the roots kick in, the leaves start pulling up, transpiring water and nutrients through the vine. And now we see this pickup of nitrogen, excuse me, again, up through about veraison. And then we see that process really kind of slow down. And then once we hit harvest and dormancy, we see that number drop off again. And we're right back to about this, in this case, about 40 grams per vine, right? And so basically one of the things that was done as part of this was also doing some nitrogen labeling work to kind of see where it distributed itself throughout the growing season. And so the nitrogen that we supplied during the season, and so in order to kind of help with this demand, basically how much fertilizer was getting picked up by the vines at different points in the season. So this is 50 days before bloom, so basically before bud break even. So you would imagine nothing gets taken up. A tiny bit gets taken up at 3 weeks before bud bloom, basically. At bloom, it started to come up by bloom, but now you can see this big demand here. And so this was one of the things that really helped us to convince growers that to stop a traditional practice of adding nitrogen before bud break or at bud break. The idea just kind of being, well, then it's there when the vines need it. Well, the vines don't need it until much later in the year. They're adding it back here, back between this 0 and half a gram per vine of fertilizer uptake. Where they really need it is here after bloom. And so what's happened now in the industry and for a lot of growers now, no nitrogen gets put on anymore until after bloom is done or at bloom, so that that nitrogen is there at peak demand and not when it's not in demand. So that's been a really effective way for us to make sure that we're improving the efficiency of nitrogen application. So more of it goes into the plant, less of it gets leached through the soil and goes into groundwater, for example. So the big thing we've learned again kind of from this, that nitrogen reserves are a really important part of it. The total nitrogen cycle in grapevines. And then that reserve is the main source of nitrogen between bud break and bloom. There's very little that's coming up from the soil at all. Almost all of it's getting redistributed from that storage pool in the below ground tissues. So I know we're running a little bit long here, but I'm going to just switch to potassium. I'm going to have a little bit less on this. Potassium, again, is one of the other macronutrients, probably one that we need to be paying more attention to than nitrogen, quite frankly, because like I was mentioning before, it doesn't get cycled in the way that nitrogen does. It's super important in all sorts of biosynthetic pathways, in building carbohydrates and proteins. One of its main functions that we're concerned about in grape growing is it helps to load sugars and other nutrients and other compounds from the phloem into the berries. So basically it helps to regulate the osmotic channels that are moving stuff into the berries and from the phloem vessels. So it's really important in that. So if we see a deficiency of potassium, we see that impacting ripening, because that sugar loading and the compound loading can't happen. Again, just kind of going over, this is a different look of the same kind of study that was done on when does potassium, what are the demand periods for potassium. So this is, again, looking at different parts of the vine. So we go from everything from really small roots, which is where most of the nutrient uptake happens, into thicker roots, into the rootstock and the trunk. Here's into the canes. This is in the active shoots, kind of this gray area. The black is the petioles. This dotted part are the leaves, and this is the inflorescence and clusters. So you can see, obviously, there's nothing in here until bloom when those start to form. And so these are in 2 different years, but basically you can see there's a big demand that goes into the leaves, the shoots, basically the leaves, shoots, petioles, and the fruit. And so the numbers, the reserves in the trunk in the roots get depleted. They start to build back up as the vine continues to take it up and use it, starts to resupply that, refill that supply, sorry. And then we see a little bit kind of flattening out for the most part. And so again, this is harvest, then we see leaf fall, for example, and then we see that most everything is back into the canes and the permanent structures of the vine. So again, potassium, big demand, basically from just before bloom through harvest. So again, dynamics of how potassium behaves in the soil is very different from nitrogen. And we can talk about that a little bit more if you have questions about it, but potassium doesn't move through the soil nearly as quickly as nitrogen does. This just gets back to that relationship that I mentioned about potassium and calcium. So I'll just skip over this. How much do I need to supply? I'm going to go through this a little bit kind of quickly, just out of time, but also this is going to be one of those things of it depends a whole lot on a whole bunch of different things. But basically, when we look at something like nitrogen, we've talked a lot about how a lot of it comes from stored reserves, comes from decomposition of organic matter. And basically, if you need to apply fertilizers, that 20% is maybe the most people would need. And so if you need any at all, a lot of situations, like I mentioned before, between the stored reserves and organic matter, you get all the nitrogen you need, and you really don't need to apply anymore. From the potassium standpoint, sorry, again, it kind of comes from the potassium from the parent materials, soil texture. Clay particles are really important in holding on to potassium, and so if you have more clay, you have better potassium holding capacity. For example, gravel soils don't hold nearly as much because of the chemistry that works there. Organic matter is also really good at holding on to potassium, so it needs low organic matter soils don't supply as much. I talked about the importance of moisture, that diffusion idea of if you have dry soils, you're not going to be able to pick up potassium, for example, and that magnesium potassium competition. So this is kind of the last major thing that I'll discuss is basically how do you monitor? We want to do two things. Monitor the supply, so that's the soils and the things that you may put down, any kind of amendments, including fertilizer, and what's the demand. And so we can do that in a couple of different ways. With soils, you can simply do a soil test. There are a lot of labs that will do that, that will provide that analysis for you. The main things you want to be sure that you get from your lab, from my estimation, the two most critical parts are the pH and the organic matter. That'll tell you a lot about what you need, what the situation of the soil is. If the pH is in the right place and you have reasonable organic matter, not really high, not really low, then a lot of the other things will kind of your life will be a lot easier when you're kind of dealing with nutrient management. So those two parts are critical. Some labs will charge you extra to know about to get a nitrogen content in your soil sample. I think that's not worth the money. You can get that basically from understanding the organic matter, the amount of organic matter. The nitrogen dynamics in soils can change very rapidly compared to the other nutrients. And so what you have at one point in the year might be very different from what you have at a different time of year. So I generally, unless you think there's a problem with nitrogen, I recommend don't bother paying for the nitrogen analysis. Just get the basic cation analysis, which is some of the other macronutrients, potassium, phosphorus, magnesium, calcium, things like that. But again, pH is the other critical one that I think you need to do. When it comes to plant tissue, the kind of that demand monitoring, you can look for kind of just visual symptoms, and I've got a couple of pictures of those. But also you can do a tissue analysis. Most labs, again, if they do soil sampling, will also do tissue sampling. Certain nutrients move through the plant better than others. And that's just a function of their chemistry for the most part. And so when we talk about phloem mobile versus non-mobile nutrients, it's basically this tells you a little bit about where to look for deficiency symptoms. So for phloem mobile nutrients, like nitrogen, potassium, phosphorus, magnesium, sulfur, chlorine, and nickel, you won't almost never see deficiency symptoms of those. But the top four, for sure, those symptoms will show up in older leaves because it's a mobile element. It'll get moved from the older leaves to the newer leaves. And so deficiency symptoms will show up on the basal leaves later in the season. For non-mobile nutrients, you will see those deficiencies develop more so in the younger leaves. So you'll see them develop more in the top of the canopy or towards the away from the basal part of the shoot. So again, things like iron, copper, zinc, those will show up on younger leaves. older leaves tend not to show those very much unless there's a real severe deficiency. I will send this presentation along so that you can have all the slides here. So I'm going to just keep moving along here just in the interest of time, but this is just some indicators of either deficient or excessive nitrogen status, kind of visual symptoms to look for. Different approximate amounts of nitrogen that are in different types of fertilizers, for example. So when you apply a certain amount of fertilizer, say you buy 100 kilograms of urea, you're not getting 100 kilograms of nitrogen that's going to get picked up by the vine. There's other stuff that's mixed in there as well, and just the amount, by the way, that the product is produced. And so if you purchase, again, urea, for example, if you're trying to get 100 kilograms applied across your vineyard, you're only going to be supplying about 46 kilograms of nitrogen. So you need to just take that into account when you're purchasing fertilizer. Same thing happens with all the other fertilizers. You should have an analysis of what the percent of the actual nutrient is when you buy a fertilizer. I'll just show you this. This is an example of extreme potassium deficiency. This is a vineyard that was a Pinot Noir vineyard that was showing these symptoms right when I first started here in the Finger Lakes. And you can see what a serious potassium deficiency can do. Reddening leaves, this is in August. So a lot of these leaves are already going dormant and dying. And on the right-hand side here, you can see very, very stunted shoots, leaves turning red. So those obviously are not going to do very much for these young clusters here. These young clusters are not going to ripen at all. So this is an extreme potassium deficiency situation. What we found out is basically the irrigation water they were using was suppressing the potassium uptake, had low potassium in it, and then had higher magnesium in it because of the pond that they were taking it from. And so basically shutting off any potassium that was coming into the vine, essentially. They were able to fix that. They were able to change their irrigation system a bit. And now they've kind of done some pretty extreme potassium additions to the soils, and now things are back in balance. This is actually a very nice vineyard now. So the other thing to kind of just keep in mind is that even though this is, I'm glad I reminded myself, nutrient deficiencies can look like other problems as well. So certain vines with potassium deficiency can look like this picture on the right, but this is actually leaf roll virus. But it doesn't look all that different, kind of maybe to an untrained eye, as these leaves do. So again, this is part of the value of doing a tissue test. When I first looked at these vines, I kind of thought maybe they had leaf roll virus because you can kind of see these striped leaves that are similar to those. But when we did tests for leaf roll virus, there was none in these vines. So I'm going to skip over this. This basically just kind of talks a little bit about how to do the calculation, sources of that. Just some pictures of magnesium deficiency. This is a pretty classic one in that you see this kind of yellowing between the veins on these leaves. In white cultivars, it's this color. In red cultivars, it looks like this. And then this is a really kind of handy table, and this might be one of my last slides, I think. This is a really handy table that comes out of a production guide that a couple of my colleagues wrote several years ago. But these values are still pretty good for the most part. We're changing some things with the bloom and with the petiole testing because we're slowly transitioning to testing leaf blades instead of petioles, and I can talk about that if people want to hear about that. But this is just kind of a good basic guide for if you get a soil test. These are numbers maybe you should be generally in this range. When you get a petiole tissue test, if you use petioles, the little stem between the leaf blade and the shoot, which a lot of places people still use, these are numbers that are kind of considered adequate or in a good range if you take it at bloom. If you take them in late summer, nutrient levels change because the vine has changed over that time, and so the standards can be a little bit different. So if you take, depending on which time of the year you take those samples, you would use different standards. And then the last thing I'll just mention very briefly is that we have a couple of videos on our YouTube channel that talk a little bit more about how to do this sampling, both of petioles and soils. And I think that is that. So that was a lot. So that's that's like I always say, it's kind of like drinking from a fire hose.
Yeah.
So
pretty much we have an hour and let's get through it.
Yep, I know. So
Awesome.
If there are any questions or things people want me to follow up on, I'm happy to do that. Like I said, I will supply the slides to Katarina and can get them to whoever would like them as well, so we can get that out to everybody.
Yep, not a problem. My question was more about, you kind of picked up on it actually, was the timing of application.
Mm-hmm.
So if you'd like to maybe elaborate a little bit more
Sure.
on that.
Yeah. So generally what we do, as I mentioned, some of it has to deal with when is the uptake, when are the times needed for uptake, and how does the nutrient interact with the soil environment. So basically when it comes to nitrogen, if you're going to add nitrogen, do it after bloom. That's when the vines will start to really need it. And that's when more of it is going to get actually taken up by the vines and less of it get leached through the soils. For a lot of the other ones, for potassium, like I said, that's usually the biggest one. Magnesium and calcium, they all kind of act the same way. Generally, what we see people do, and it makes sense to me, is gets added like after harvest, or even first thing in the spring, because it needs having some soil moisture, whether that's a lot of it gets put on in the fall because then we have snow melt where we get snow like we do here in our areas. That can help to move that material down into the root zone. It doesn't leach through like nitrogen does quickly. But it can get pushed down into the root zone, and then so by bloom time, more of it is in that root zone for uptake. So generally, for the macronutrients, except for nitrogen, fall or early spring, kind of depending on when you can get in. Nitrogen after bloom. The micronutrients are probably best dealt with if there's a deficiency by doing foliar sprays, because they need so little relative to the macronutrients that you're better off supplying it. The leaves aren't great at taking up nitrogen, at taking up macronutrients, but they're pretty good at, because the numbers are so small, the amount of micronutrients, leaves are a pretty easy way to get micronutrients into the vine. If you try to sprinkle a little bit of boron or iron onto the ground, you definitely can do that. But it's going to be such a small amount, and it's going to get really diluted by that huge soil environment compared to the amount that you probably need in the vine. And so generally, foliar applications make more sense for the micronutrients.
Thank you. Patrick, you had a question?
Yes, or it says that the chat is disabled.
Oh,
so
I'm sorry.
I put my question in the Q&A section.
Okay.
But I can ask the question, I guess.
Yes, please do.
Just on the guest speaker's opinion on using calcium ammonium nitrate in the vineyard as the primary nitrogen source besides the natural one.
Yeah. So it's, regardless of the nitrogen fertilizer you buy, it comes down to what they call the percent actual nitrogen in the material is. So with calcium ammonium nitrate, the ammonium nitrate is the nitrogen source. And so when you buy that, it should include a percent N, percent actual, something like that says that. Generally for calcium ammonium nitrate, I think it's around 25 to 28%, kind of depending on the provider. But when it comes down to it, nitrogen is nitrogen. And whether it's calcium ammonium nitrate or CAN, we call it, urea basically breaks down into ammonium and nitrate. So they all eventually are in the form that the plants will take up. So as long as you get that percent nitrogen number, it'll behave like any other nitrogen fertilizer.
Okay, thank you.
You're welcome.
Okay, we've got 2 more questions. So we've got the next one is, if splitting fertilizer applications into 2 to 3 applications, how would you time them and what rates generally speaking?
So most of the time, the only fertilizer we generally could talk about splitting is nitrogen, because of that leaching potential. And so so if you're looking at splitting nitrogen applications, I would it depends on your soils, quite frankly. If you have a really kind of gravelly or sandy soil, so that doesn't hold nutrients well at all, I would probably do 2 or 3 splits, exactly like I was talking about, but I would do them starting right about bloom, and then do a couple of after that, so that you're almost kind of more spoon feeding than putting a whole slug down at once. If you have a more fine textured soil, so a lot more silt or clay, you could probably split it in 2. I personally think splitting nitrogen applications makes a lot of sense, again, because you're reducing the leaching potential. So yeah, I would my recommendation would be, it depends on what kind of soils you have. If you have a like I said, if you have a more coarse soil with not a lot of silt and clay in it, that's not going to hold on to that nitrogen as well. I would split it over 2 or even 3 applications if you can.
Great. And then we've got another one that says, is it wise to vary soil pH in order that the vines get everything they need?
Is it wise to vary soil pH? Soil pH is incredible. If I'm understanding the question right, soil pH is not easy to manipulate. There's a lot of soils have a very big buffering capacity. So if you need to, let's say you have a soil that has a pH of 5.2 and you want to get it up to 6.5, 6.5, you're going to have to add several tons of lime to that soil. And it's going to take time for that lime to kind of percolate through. We were talking about how things like potassium take a while to move through the soil profile. Lime is even slower. It moves very slowly through that. So the better you can adjust your pH before you plant any vines, that's going to be a much better way to do it. But I think it's hard to kind of create different pHs in different parts of the vineyard. You might have that naturally. There might be some locations where there's more limestone and other spots that aren't, for example. But trying to manipulate soil pH is really, really difficult. And so it's hard to, so when people are trying to adjust their soil pHs, generally the best move is to kind of do it bit by bit. So if they say you need 10 tons of lime per hectare to get your pH to move from here to here, instead of adding 10 tons in 1 year and just waiting for it to all go, I would say add 2 tons every year or every other year until you get that 10.
Okay.
So it's more of a process.
Yeah. Okay, so any more questions? Please put them in the Q&A, because apparently our chat doesn't work. But I think these are the 3 questions that we had. So if anyone has any more, please email them to me and we'll get them answered for you, no problems. I will also post this video on our Perennia website as well. And as we've also been told, the presentation will be available as well.
Yep.
So thank you very much, everybody. Thank you very much, Hans, for joining us today and having this conversation with us. This has been an excellent discussion.
My pleasure.
And we'll see you again soon. Thank you, everyone. Bye-bye.